Welcome to another 5-minute session, and this time about vector math, specifically the cross product. So if we look at the cross product, it's like this, that if you have two axes, the third axis will be calculated using the cross product. So if I have A and B here, you will get the z-axis by 90 degrees from A and B. So you can see here in the animated example that if they are exactly in the same direction or in the opposite direction, you have a value of 0. Otherwise it could be positive if it goes in one direction, or it could be negative if it goes on the other direction. So I will show you a bit how you can use that in Blender. First of all, we can just do some simple thing here. So I can select the plane, press tab, press 2 to get the edges, and just extrude. So E, Z to drag up here. Yes, I have something, and I can go pressing tab again, and then we have it here. And now I can go in here and select texture coordinate. So Shift A, input texture coordinate, and I can also put in a cross product. So Shift A, converter, vector math, and here I can select the cross product. So we have it. And if I now take this into normal here, and I take the object here, and I drag this to the base color, go to render view, it looks like this. What is the purpose of this? Well, we will add an empty as well. So you can see Shift A, and then I go to empty, plane axis, go back to texture coordinate, but I change this to empty, and I use this empty here. Then if I move that up, you can see it follows the empty. If I rotate the empty, RZ, it follows the empty. So I can control another texture using the cross product. So let's say that I add a brick texture here, Shift A, texture, brick texture, put that in to the vector here, and start to rotate, then you can see that the texture follow along. So that is one way to use it. Another way is to get the third axis as shown in the example in the web page that you saw, and that we can do by using a rotate. So Shift A, and then go to vector, vector rotate, and then I can show you here by using the object to the cross product, and then take this object to the vector and take that to the cross product as well, but exchange brick texture into a length. So Shift A, and go to converter, vector math, change this to length, and I will add a subtract, which will make it look nicer. So converter math, put in a subtract, and put that to the bottom and then out here. So now we have something here. Can change this to smaller value, put in a clump here. So if I now change this angle here, you can see that it shrinks on the length, and then if I continue, it will grow again. So I'm basically doing what we did on the web page, that I rotate this. So if I select the vector and select separate, X, Y, Z, and take the X here, you will see now that I'm just rotating the X and the Y by just selecting that. I will rotate around the Z axis. So I don't move it up and down. Still, by using a cross product, the length will be bigger and smaller, so it will change the height of the Z axis by rotating X and Y. So you can do that if you would like to simulate rotation of, like, say, a planet or something on a plane surface. So that is another thing you can do with it. And the last thing I could show you is how you can just use it for aiming. So if I have it like this, I can take the subtract here and take away that, and just take normal here and take object here. You can see now that you get aim here. So if I move this GX and then rotate it a bit, RZ, you can see I get aiming from the cross product. So you can use that if you want to make a laser beam or something like that as well. So there's a lot of potential to use cross product here, a lot of stuff, but it's rather complicated in some cases, even if these examples was rather easy. But now we have touched cross product and know a little bit what it's doing. So hopefully you learned something today as well. And I just say bye for now and see you tomorrow.